1. 3, 2, 1, action!
Stop! That actually did happen once.
Are you serious? Really?
No, but I've had similar stories.
Well, yeah.
No, like.
That's happened once
Okay.
to someone out there.
Wait, no. My little wait. This is a walk to Baker story.
I can't find the good
My brother
You know if you like sprained it?
was older, and so he had some stuff in like the hidden compartment of a feet. And I go to my 4th grade class, and I feel it inside. I'm like, wait, that's not grass.
How old was you?
Oh, he was like a high schooler. So not legal, but not legal, but well, because it didn't look like grass. It was green. And
Or literally, see,
Don't see banana butter.
It's not.
Evan, do something.
Oh, it's not meat.
Imagine how much time you would save instead of letting it.
Yeah.
Imagine how much time you would save if you never walked outside and appreciated the sun. Sometimes you have to spend time ever.
Enjoying the
Yes.
SIN?
Sign is literally staying.
Okay. Hi. No, there's a new thought. Yeah,
Never heard.
there's a guy who's doing some interesting stuff with it. It's not me, actually. Okay. You ready? Okay.
Hi, Christian.
How is that funny?
I have a really bad poker face.
You can never hurt a Calc class with a midterm.
I can't even keep the face. When we're babies, and we drop our milk bottles, we cry. Because it is literally the worst thing that has ever happened to us in our lives. That's all the perspective we have. And now many of you are probably, you finished the exam and I've gotten a flood of faces, fears. I got an apology. I got an apology.
An apology.
Someone I won't say, but it's wonderful. You are very wonderful. Because, yeah, it's okay. But then again, you're all getting your butts kicked by certain aspects of MIT now. So before I even talk about exam scores, before Chrissy ever responds to my text about doing this for you all, I'm just going to do it. I need to make sure that I'm rigged up to audio for this to work. So I'm going to check that. Am I hooked up to Crestron? How do we know if it works? We'll just play some bossa nova. And we'll know if our audio works. It looks like our audio doesn't work. Oh, no. Spotify broke. This thing thinks it's muted, but it's not. It's an internet thing. And lo and behold, can't play it. So that's a different kind of problem that we're having, which is fine because I'm from the era of iTunes.
Deftones?
Oh, hell no.
Whoa! Deftones?
It's a love-hate relationship.
Which means I bought all these songs on iTunes when I was younger anyway, so I have the MP3s. So I don't need the internet to tell me when I can or cannot listen to music to test audio, except the QuickTime's not very happy with me either. I didn't give it a calculus midterm, that's just a quick review it. That'll go, yeah. Okay. None of the audio logic on Mac is happy with me. I'm gonna get a beach ball in a moment. Whatever. There we go. That is a good boy.
We had a couple students doing the acapella.
It thinks it's muted, but it actually it thinks it wants to be muted. Okay, so we are, where audio is concerned, we are muted. I'll try one more. The W.
That just implies that I wasn't listening Christian. That means that my inability to listen to Christian music was before this degree, which is not good.
Decimal meter, but I can prove that.
Oh, you're right.
Got no eyes.
But then there was a Russian lobby, and I'm like, that's good.
Okay. I'll go off of audio off of the thing. Okay, hi, yes, I'm very angry with all of you. Redhead told me I should print pictures and like leave them around so you find angry pictures of baby me. Yeah, I didn't have time to laminate them, so they're not here right now. And she'll give them to you in chemistry. Okay, so yes, so Chrissy hasn't responded to my text. I'm just going to give you the talk. Also, the birds and the bees never made sense to me. Because in my mind, I think birds want nothing reproductively with bees, right? Turns out that's symbols of fertility. Okay, this is the way that you see the world, yes? And this is where you see yourself. And this is where you see that person who like asks all the good questions during lecture, and is attentive and does their T-shirts on time, and scores hundreds on the midterm. No one scores 100 on the midterm. But like that's not a diss really. So you all see, and this is going to happen to you long beyond this class. It's probably happened to you in other classes. It will happen to you in undergrad. I have two pieces of advice. The first one is what you're looking at here is a very, very zoomed in version, a very teensy microcosm called MIT. That like really good school that you got into. So it's going to be okay. Number two, you think that the people on the alleged top know what they're doing because they sound like they're talking, they know what they're doing. They stand in front of classrooms and they say things, they sit in the front of lecture halls and they ask questions. But what did Buzz Lightyear teach us in Toy Story? Flying is just falling with style, because even though you think there's a top, if you really zoom out and you do another coordinate perspective, it's all a flat line. And that's okay, it's beautiful, because it means that we're all to some extent fronting. Yeah? Okay, cool. What else do I want to say about this? I once had an ego. Welcome to MIT. When I was a freshman, I was in a class called Production of Educational Videos, where we had for our first assignment something called a life stream, which is just talking about your life and the state of your life. I'd like to show you mine. This is freshman Christian. This is a freshman Christian video not learning. We're going to fix that. Start movie. On click it says. So in theory. No? That's okay. Nothing cooperates, and we zoom in. Sorry about the audio. It's like a Michael Scott video from when he was in that kid's sitcom or something.
Hi there, I'm Christian Cardozo, and these are a few things you should know about me. I've been around for 18 years now, the first few of which I spent crawling and running through my home in Miami. A year after I entered elementary school, I was chosen to host a NASA-sponsored science series. Then came second grade, third grade, fourth grade, you know the rest. I started playing the saxophone when I was around 10, picked up video editing on my Mac, started taking pictures of myself every night. By the time I had a chance to blink, I had started my years of high school. Excitement ensued. I became VP of my school's science and engineering club, made my two closest friends and many more, graduated first in my class, and oh yeah, that too. So I went to MIT. Took some classes, taught some classes, and became a sophomore after my first semester. And this year, I started doing research, became a teaching assistant, and enrolled in ES 333. And this, I'm glad to say, is just the beginning.
Yeah, this guy didn't know anything. MIT had this thing called early sophomore status, which like all the ASCs you're all trying to take is a massive attempt at an ego boost. And the idea of it was that if you had enough general elective credit and stuff, you would become a sophomore, and your second semester freshman, you'd get a department advisor, you'd pick a major, and you'd do everything that sophomores did. Because you'd be ahead, and it's good to be ahead. It's good to be ahead because in high school, this is the sort of mentality, right? It was to get like A's and everything. Yeah, stuff like that. Yeah, screw that. Let me explain. I tried that. I became a sophomore after my first semester, and I recorded that video at the start of that semester. That semester, I failed a class and I had to drop another one because I was convinced that I was going to be able to game MIT to be like high school. Yeah, it didn't work. And you may need to find that out your own way. I'm not here to tell you what to do. I know a lot of you are like scheming and all sorts of stuff, and then the Course 6 internship factory has you going soon, right? But I promise, guys, like breathe, like a year. It's fun. If you don't take things so seriously, it's actually kind of fun. My master's thesis, by the time I grew from this to this and now grew the tie a little bit, was called Many Interesting Things. Like, what the fuck did he write for his thesis? I can't even tell you. like, yeah, I worked at a biotech startup that built fancy lasers, and I was too busy trying to heat my coffee mug. This exact one. Anyone know why this is a bad idea? Well, metal conducts electricity, so you think I'm doing a good job. What's this thing's only goal in life?
Not
Because it has no control over how crappy the coffee is.
Insulate.
Yeah. So when I went to grab my coffee that I thought would be hot, I was met with burnt hands and some really sad and cold coffee. So, okay, so let me just check what else is in the slides. Ah, yes, okay. So all of this to say, again, none of us know what we're doing.
I don't know.
And this is the part where I remind you that you probably saw your midterm grades because they're on Canvas. And if you didn't, don't rush to look at it, it's okay. Just bring the vibe from this conversation with you. The real question you want to ask is oh no, that's not the side I meant to copy. There it is. Is 10-year-old version of you pleased with you? And one way to evaluate that might be to look back to a movie you were born when it came out. It was called Click by Adam Sandler. Anyone's seen it? You've seen it?
Yeah.
Oh, Jesus, okay, so you know what I'm talking about, sort of, maybe. The tangents could take us any direction with this, so I'll elaborate. What's the premise of the film?
Yeah, okay. So Adam Sandler has this
Okay, speak up. Speak up.
Adam Sandler has this like TV controller that lets him control time and lets him skip things and like fast forward through things.
Right.
Right. So he starts fast forwarding through stuff. This controller, like, it gets faster every time he fast forwards, and he starts losing out on experiences he had. He starts like just skipping through everything and going fast through life. Right, so he says, no, I don't want to do that. I want to go back and have fun with my family. He is successful. Like, he becomes successful. He realizes his dreams through the controller, but he never lived through any of it. So he decides, the controller was given to him by like God or something, right?
No, you're thinking Bruce Almighty, which is from that era. No, into people, the one who emphasizes the different words, instead of scuba diving, he'll say scuba diving. Christopher Walken, there we go.
Well, it was given to, the controller was a gift
So like
from some like heavenly figure, right?
Right, yeah. That's
So, the heavenly figure lets him like go back and live his life again, and he decides to do that.
Spoilers?
yeah, I'm sorry.
It's not that good of a movie, guys.
But I think it drives a point home because when he fast forwards into the future and he realizes all these dreams, he's not really happy, is he? He's appalled at who he has become. He's not happy with the way that he chose to live his life and the things that he sees that he did to get to that point, because he runs on autopilot to get to these various points in his life. And that movie in 2006, I think it was 06, it inspired a sort of mentality in me that I keep around. And I would encourage you to see if it works for you, because I'm not the Dalai Lama, so who am I to tell you what to think? But I like to keep a version of him inside here at all times, and he's watching through my eyes, but no one's explaining stuff to him. He can only reconstruct it. Like when you're in an out-of-body experience and you're trying to reconstruct what's going on, like where am I, right? That's what he's doing right now. And he's realized that he's in the body of future him. But the question is, based on what he's seeing through this movie projector through the eyes, is he happy? Is he happy with who he is going to become? And if the answer for you today is yes, that's pretty fucking cool. And it has nothing to do with how you get on this midterm. Pardon my French. So that's how it was sort of for me. And I didn't realize this easily. I flunked a bunch of stuff my sophomore spring at MIT. I probably discovered it too late. But you sort of figure out that you are more to MIT and certainly more to the world than what you are to MIT academically. Okay. So that's my bit. And yeah, don't take yourself too seriously. Look, I was shoving a piece of, I forgot I had the slide here actually, but yeah, that bread did not fit up my nose, but made for a picture, I guess. So yeah, it's all right, you guys. Okay, and now in terms of scores, a 70 is like pretty good. So if you scored a 70, you're good. I think if you score within one standard deviation of 70, you're pretty good. So that means that if you scored 55 or above, it's not too bad, not too shabby. If you score below 55, chat with me for your own good, because we'll have office hours, we'll meet one-on-one. My interest is not that you can tell me what a line integral is 2 years from now. It's do you remember something meaningful from here? questions. Do you want to ask me numerical questions about the test? That's okay too. Yeah.
Next time, I feel like a lot of questions were very conceptual, and like you had to really think about it.
Yeah.
Is there a way or a framework that you would, this is more of an option question,
Yeah.
actually, a framework that you would kind of like urge us to do when we look at these sets to kind of be able to put one to one together?
Part of it is practice. I think the biggest way you learn it is by teaching it to somebody else at a high level. I don't know if that helps, but if you, this is why I encourage the pyramid scheme. Who has pyramid schemed in this class? Not for like Nutra or Herbalife or something. It works. Is it reviews on pyramid scheming? Sadie? You raise your hand for pyramid scheming?
Oh, yeah, I love her.
Did it get you to get better at teaching this stuff? Yeah.
Yeah, I think so.
All right. All right. Who else is pyramid schemed? You pyramid schemed? Who else? You pyramid scheme, yeah. So all three of you, I'm not saying no.
What if the
but
top of the pyramid is just kind of like bad, so it's a really bad game of telephone?
the fact that you're teaching it to somebody will reveal the flaws in your own understanding to it, and it'll force you to reckon with it. Also, and I can't stress this enough, ChatGPT is actually really helpful, I promise. Like, I'm not saying use it to answer your PISA questions. You all have academic integrity and whatnot, but like, the same way that you can talk my ear off for hours about Calc, and I can, keep up with you because it's fun. Any questions you're too embarrassed to ask me anyway, but if you're really embarrassed, ask GPT and break it down. I have an assignment that I do for first-time TAs, and I ask them to, I give them a random topic that I know they don't know anything about, and I tell them, spend 15 minutes with ChatGPT, come back, and teach it to a 5-year-old. And I bring staff's children, and they get it. But like, it's really, really effective. I've never learned more about linear algebra than when I taught that 8-year-old with the baskets about linear algebra. So teaching is the best way to learn it, I think. Does that help? No, everyone has their own way. So if I stood up here and told you those YouTube videos, this is how you get into MIT, right?
No, I got it.
But you can buy my online service for $50 an hour, so I can tell you how to get into
I
MIT.
got my class subscription now.
Yeah. What do we call it? Christian Plus? Well, like Christian Minus. All right. Very cool. All right, can we get the lights on? And we're going to start on double integration. It's going to be okay. Yeah, it's what you thought you'd be doing when you walked into this class, not this crazy linear algebra crap. To that end, I would need some help, and I'm sorry, but you've gotten too reliable. You too, Sam.
Oh no!
Oh, I'll get you that. Don't worry.
Sorry.
Relish?
Mustard?
I love relish.
It's the wildfires.
Yeah. This wildfire.
The world's best bird.
Reaction. Double integration. My favorite type. Oh, that's from chemistry. That image.
Oh, no. It's like, thank you, Conceptual. I didn't know what this sound was.
It's on that video that I took you to no, that's like two, and then one.
No, y'all for sure. Okay. All right. In high school Calc, we felt very cool. Period. But in high school Calc. Oh no. We felt cool for doing this. This is a bound from A to B. This is the total area, A, and you get it by adding up these little slices. This is the area. This is high school. Cool. High school, according to your brother who passed you that magical grass. Oh, right.
Oh, right.
Sorry, no context. Okay, so y equals f. Oh, there's a story there, but I come to office hours, I'll tell you the story about the time I shoved a cigar up my nose and thought it was going to die. All right. So area is equal to the integral from x equals a to x equals b of f of x dx. What the heck did this even mean? The if we understand this at a deeper perspective, we can be college students. So, what did this mean?
Can we take it back to,
Well, what?
can we take it back to the summation?
Sort of, but
Or is that too much? Just make it basic?
yeah, I didn't even want to go that little.
Like times width equals an area?
Yes!
Wow.
Okay, this is what I'm driving for. This is a point x. This is a point x plus tiny x, delta x. But we're adults. So tiny that we have a special secret word for it, dx. It just means differential, right? Little piece. We couldn't even be bothered to write the whole Greek triangle. And we have the fact that then this width is dx, okay. And what do we know? We know that this height approximately, if we zoom in on a little sliver of this situation, if we zoom on this little sliver, hey, this is an ellipse. Oh. Too soon? All right. And we know that this height is approximately f of x, because as with the, I hate to do it, but as with the tangent plane, remember if you move just a tiny piece off of your point, you're just about at the same sort of behavior. So for this tiny sliver of x dx, for this tiny sliver over here, f isn't changing enough for me to call this rectangle's height anything other than f of x all throughout that little piece. So this whole thing is a little piece of area. And that little piece of area is that height times this length. Okay. So this is, yeah, I need to buy more domains. Did I tell you about little backpack? So little area, this is height, and this is little width, or little length, depending on, I'm gonna go with length, but, no, yeah, I'm gonna go with length. But just because I'm afraid that if I don't, then something in my notes will kill me later. But I don't disagree with you, no, it feels more like a width. So write it down as width if you want, but then I get to pay for the consequences if that ends up being inconvenient. So to get the total area, we add up all the tiny chunks of areas. We add all the tiny DAs. We get these little slivers, and we add this sliver, and then we add this sliver. Just keep swimming, which is what I was watching right before I went to track this midterm. And we add all those little pieces of dA, and when we add them, that becomes the sum. Now sum, just like we have our little d for our delta, our sum, rather than being a sigma, because this is very, what does sigma mean? Help me.
Summation.
No, I know, but like
Sigma.
like when someone is sigma, there's skippity sigma.
They're like, they're neat.
Okay.
Okay.
So sigma, notation is the same as Noah. You're still calling it capitalized first letter. Alright, so it's the sum of the DAs.
So like myself and other
and that, those little pieces of area are themselves
and then
f of x times little changes
oh no, actually
in x. Alright,
and
so it's the sum of all the little heights
well, we can't do that because
times
houses are
little
low,
length.
we can't move them, or there's people going back to my team.
Okay.
Where X is and they told me.
This is a lot of English, which is cool. We've been doing a lot of
And then
symbols lately. Nice to keep it English for a little while. That upper right bit doesn't really need to end up in your notes. In fact, nothing needs to end up on your notes. Post these and we record. So that's another thing during lecture. If you're rushing to copy down exactly what I'm writing, you might be missing out. So figure out a good balance. Okay, so we're going to rebuild integration from the ground up, and at the risk of being repetitiously redundant, I will say this. Total deconstruction of integration. The different pieces will be as follows. This is called the differential. Okay. This is called, what is the thing inside the integral, Carl?
Integrand.
Integrand. Do you guys have a good way of remembering that?
You just know it.
You just know it? That's me, but I don't know.
It's a differential and an integrand.
But I feel like that could,
That makes
okay,
no sense.
as long as it doesn't backfire. Okay. And then what are these called?
If they're not giving me
The bounds. Right. Going back to doing integrals, what if the integrand, this is going to be a really useful one. So now that we've broken down what an integral is, here's a question for you. What is integral from a to b of 1 dx? Yes, but in English. The English will help us more.
Area of
Sneaky, sneaky. Think about dimensions. Think about.
Oh, 1 by
The length.
minus
The
b
reason
minus
I'm like,
Oh, you all want area out of this.
they did the same
Ooh.
thing where
I mean, like,
they kept changing the rules.
I mean, so you're not
And
wrong.
they funded
Actually, I don't think
until
about
it
it.
was too late.
And there's another geometric way to do it. Yeah.
Sorry, we like to have the font footage.
wait, BA is like the United States of differential.
Well, yes, you're right. So what is dx? That differential. What is it in English?
It's a little length.
It's a little length, right? dx is a little length. What are we doing when we put a big s in front of it? You're summing them. So if you add up all the tiny pieces of length, all the little dx's, you get x. You get length. You get the length from A to B, which is, what is it now? You can use your algebra.
Indira.
No, but you said it earlier, Noah.
I agree with
Oh,
that.
I'll put her on the spot later. You got to do
The
this.
area, no.
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 It's the first thing you shouted.
The different, B, A is differential.
Do you mind saying? You did say that. I don't know.
It is worth my housing contract.
There was no grass in my backpack.
Wait, so that means one, it's like the length of A to B times your F of X.
Yes. So there are two ways to view it.
No one told us that it'd be such a-
In order to blow your minds, or rather make this robust to when we go to higher dimensions, the way I'm going to recommend it is to divorce yourself from the notion that that an integral has to mean, sorry, that a single integral, one integral, needs to mean area. A single integral means a certain quantity multiplied by length, and then you add up all those problems. Okay. So one integral is length. But I know you all like area, so we're gonna go for a moment. But before that, let's keep going with this theme and just do everything we've seen with single integration with this new mind perception. Okay. So the first thing, and I feel like I gotta be more consistent about what's yellow, because if everything's yellow, then it's like every word being all caps. So we're gonna go back to this. Okay. So the first application of single integration we've seen is this. This from A to B of dx, this gives length, right? If we have from A to B, and we add up all the little x's, you agree with me that this amount is L. Okay, but now I know what you want to do. You want to do the following, you want to find area. So here's a question for you. A to B, an integral from A to B of what? What can I multiply by my little pieces of length to get an area, to get a little piece of area? Height. So this I'm going to call most broadly height as a function of x dx. This gives area, and this is this is area.
There's two levels inside of you. One is from.
Okay. A few more that you have seen. They're kind of fun.
Specific class.
Let's do it. What's this one? This is going to be integral from A to B of f of x over b minus a dx. What is this?
She said that I had the best.
So this is similar. Yeah. What many sig figs in here? Are you glad or not glad?
Three sig figs and then the average.
I concur.
What's that? What's that? Concept? Bond said.
Average
Average value, yeah. Gives average value of f where?
I never.
From the,
The only
Yeah.
reason I knew what I was writing.
Average
But I was like half
value
the entire time. For
of
some reason,
F
every time I had an assignment, I just forgot
between A and B.
the last minute and it's just like when Clueless was unnaturally high.
All right.
So,
Do I have one more for
it
you?
didn't have to be.
Yeah.
Yeah, this one's fun, this one's fun. All right,
They weren't hard to science, they were just tedious.
Yeah.
integral from A to B
There's many times where like I could
Of,
submit something like
yeah.
11, like 58,
Of
and it would just take 18 minutes.
density
And I got it.
as a function of X. So tell me what I'm multiplying out here in English.
Like I did it on time.
mass
Is
over
X a
volume.
mass?
Yeah, X is mass per unit, density is mass per unit
And
length.
the next day after that, I would try to-
So if I take mass per unit length and I multiply it by a tiny piece of length, what do I have? Tiny piece of mass.
Oh, and if you think about
If you add all the tiny piece of mass you get,
better mass.
no, it just gives mass. Right?
Oh, yeah, you divide by the
Ah, so let's do it, because you all are in physics. Yay! So how do I find, this gives me the mass, right? Tell me what you know about center of mass.
I genuinely cried because I saw this.
Good words and continue. Oh, but you think one. Oh, no, that's right, you got it.
I thought it was really good. I hope you appreciate it.
That's, where both sides are equal mass. How do you calculate, who remembers the equation for center of mass in physics? Yeah, Lily. It's a weighted sum of them, on the pun intended, huh? It's a weighted sum of them. That's pretty good. Like, you weren't trying to make fun, that's pretty good. Alright, yeah, guys, the center of mass, first off, when you find center of mass, what do you divide by? The total mass, so 1 over mass. And then, what are you going to do for each point? Find its position, and you multiply it by its mass. So what do you think the equation in the integrand is? It's x times, yeah, density, as a function of x, dx, gives center of, that is x center.
My question.
Yeah.
So, E minus A was.
Oh, center mass, mass of the part of this that is between A and B.
Oh, so we solve for that, and then we redo it again to then.
Yeah, yeah, you're right, yeah, that's a good point. Yeah, so you gotta find this to do this. And this is not the mass of this is the mass of what? What shapes am I finding the mass of if I'm in this number of dimensions? Lines, I'm like weighing your out pencils. It gives mass in 1D, and this gives center of mass in 1D. Okay. What are A and B represented? The endpoints of your object. Yeah. So like if your pencil went from -2 to 2, that's your object, then your bounds are -2 to 2 next. Okay.
So E minus A had to be the length.
Yeah. Well, actually, we need that.
Oh, the
Yeah. Yeah. In fact, maybe. Oh, that's a really good point, Noah. Hey, this gives you the average value of f over that length, right? What's another way I could write this that's more general? F of x and put a 1 over what over here? Think about what we did for center of mass. 1 over length. 1 over length times the integral of the function over that gives you the average value of the along that length. Okay. Questions?
I have a question.
Yeah.
So like, can we like write length also as an integral?
Yeah. I mean, it's kind of showing off if you do it in a single variable unless it's pedagogical. But yeah.
Is that like evil?
Is that what?
Never mind.
I don't know what.
I was like asking if it was evil.
It was evil.
Yeah, evil, as in like
Diablo.
Yeah, like Diablo. Sort of like that would be a really cruel trick question in the exam. Like, oh, no, I'm just thinking. Like, we're not talking about trick questions on the exam here. Understood. You don't grow up watching the Fairly Odd Parents on the.
I wish for a kids class. We were talking about this earlier.
Yeah. Do you remember the one where like they always go back to that one wish that he made that was awful, super toilet. And then whenever he says super toilet, the guy's like, no, no. Ah. Anyways, I hope the midterm doesn't feel that way. It's fun. All right. Are we cool with what we've done for single integration? My hope is that by looking at it this way, double integration stems off as a natural, progression from this. So questions. Are you cool with us being pedagogically this way about single integration? Questions?
Yeah.
Go on, you got a question? Oh, okay. Oh, yeah, as in all good. Okay, cool. Yeah, again, if this were the 80s, like you'd all had your cigarettes and I wouldn't have allowed a question, but school was just taking a hit. All right, let me erase some stuff. We are now going to set this up in 2 dimensions. I told you about little backpack. I don't know if I told you about little backpack.
Now it's time for a little backpack.
Yeah, there were so many rappers. Everyone was little something or other.
That's how
And in 2020, like around COVID era, everyone was wearing those tiny backpacks.
the hype beast.
That's what they're called?
Yeah.
Yeah. So I thought, there's even a little baby at this point. I'll buy littlebackpack.com, and if someone wants to be a rapper, names himself that, they'll have to buy the website from me. And no one bought it.
Wait,
This is a 5.
Christian, you're listening now you're listening to a lot of
Oh yeah, I'm still working on E. But I'm a big fan of old Kanye, the first 3 albums.
Oh my
I
god.
love the top. Or that hurts me. Yeah, I said it to them my whole sophomore year. Okay.
I'm not.
All right. Now we're going to move up a dimension.
I think reach out to the office.
So far, we've been adding up little lengths. What do you think is next? Little areas. Yeah, .com. All right. So here we go. Integral. And I'm going to show it this way. This one's a little tinier. A to B, C to D, dx, dy.
It was just a good general
Question, what are we adding up? We're adding up little areas. This, dx, dy, is what? If I am in my beautiful 2-dimensional space, and I make a tiny change in the x direction, dx, and then I make a tiny change in the y direction, dy. Then my little chunk of area, dA, which is dx, dy, or what else could it be? 5 times 3 is the same thing as, yes, 15, which is the same as 3 times 5.
Oh, you can, oh, right.
Yeah. So, now this, in terms of the little piece of area, order doesn't matter, but it will affect your bounds, and we're going to spend a lot of time talking about how not to let that mess with you. All right, so again, this is a zoomed-in picture, just like the whole MIT graph, of the following. You are going from A to B in the x direction. You are going from C to D in the y direction. So you've got yourself one of these guys, and this little piece of area, ding, 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 is only a piece of your total area A. And naturally, again, that area is sum of the little sum of, I'm make sure I get my orders in the way that I want them. dy, I'm going to C to D, bless you, dx going from A to B. Now, what is area? It's the product of 2, what? Just geometric. 2 lengths, right? Well, what is the integral from C to D of dy? It's the y piece. It's this thing. Right? That's this. Okay, and then what's this guy? You're going to multiply this by what?
By the delta of the.
By the change, yeah, the b minus a. So you're taking this and you're basically extruding it this way. What's not your one?
No.
I mean, you got it.
When we're doing it one step at a time, we really don't care about what the x is until after we do it, though. It's that's important later.
Okay. All right.
Wait,
So-
why did you switch from dx to y?
Because areas.
Did I screw? Oh, how do we change from this to this?
No, from the very top.
Oh.
corner.
Yeah, I think I was just messy.
No, because the bounds still work out.
C to D.
Is that-
Oh.
is that a
Oh.
Yeah, it's commutative property. Because it's an area.
Well, it's commutative property, but watch out, because the only reason this works is because it is a rectangle. I want to talk about why this isn't, like, changing the order and just flipping the bounds only works when the variables are not functions of each other in the region of integration. But hang tight, because that's part of the progression we're building here. So for anything square or rectangular, does this make sense to all of you? Okay. Now let's expand. Oh, well, first off, what is the integral of? What's the double integral of dA? A is the area. it's a box I have to check, but you sign waivers at climbing gyms, so luckily no one got hurt. I still go, I ran into Ashton a few people the other day. You all come, let me know. It's gloomy weather outside. Oh, office hours today, 4 to 6 the usual. Okay. Now, we don't want to just find the areas of boxes. We want to do a little bit more now. Though Patty Christie's sick, so maybe she won't be saying it quite so vividly today. But let's draw ourselves something a little more interesting. Here's our x-axis. Here's our y-axis. How much time have we got? Fun. Okay, so here's one function, and here's another function. This is y equals fb of x, and this is y equals function a of x. That's all the little a means. It does not mean a derivative. It just means, you know, function a, function b. All right. Now, let's find the areas here. The region that I want to find the area of, if I can draw a straight line, goes from x goes from C to D. And that's all we have. So we want to find the area of this region. And we're going to use this as an introduction to how we do this. Now, first off, let's set up an integral. We know it's going to be double integral. This is how you score partial credit. This game is called partial credit. And the way I'm going to set it up is as follows. I want to have sums of areas of tiny rectangles. I'm going to find first the height of these little rectangles. Now, is the height of these rectangles constant across my region? So are we in rectangular land as a whole anymore? The whole thing is not a rectangle anymore. But for any, you know, non-specific rectangle, where does its height start? If I go up, where do I enter my region? So this entry point is called y is fa of x. Does that make sense? All right. The first variable that you use, that ought to be your inner variable of integration. So I have then made the executive decision that we're going to do dy first, and then we'll do x. So we enter our length, or our height. Yeah, we enter our height at fa. So our lower bound is fa of x. And where do we exit? Let's go up. Where are we coming out? Okay. At this point, we have taken care of the dependence between our variables. Because y is a function of x. Right? Once we've handled the dependency between our inner and outer variables, we can now say that the outer variable x goes from one constant bound to another. That's C to D. Okay. Does that make sense? Does it have to make sense? This might be your first time doing double integration. It kind of was meant to be. Yes. Okay. All right. So that is this order of integration. Now, let's mess with this a bit. I'm going to do the same exact thing, but I'm going to switch up the order of integration. So let's actually, let's do it here. Try to, oh yeah?
I have a quick question. Why can't you just subtract the ones?
The f of b minus f of a? You can. And in fact, that's what you learn in single variable calc, right? What is your integrand for area in single variable calc? Height is a function of x, right?
Yeah.
Cool. And that height is going to be this minus this. So your single, that's a really good point, Diego. Your single variable calc intuition doesn't hurt. Jump back to it. But where does stuff start to break down? Is if I ask you again.
Oh, I was going to say 3 dimensions.
3 dimensions, but it doesn't even take 3 dimensions. Because remember, for each of these, all that I'm finding is an area. I'm finding a length times a width, right? But I would now like to introduce you to the idea that there are quantities other than volume with which you might be interested. Let's say, for example, What are some applications of double integrals? All of these guys. Density, yeah. So let's say that we want to find, we want to do density, we want to do, yeah, I want to, moment of inertia is another good one, I didn't do that. No, let's do, what did you say, center of mass? Okay.
Because really that gave us an area. We really need a volume.
Well, yeah, so volume is a really good example, but I'm afraid that if I go that route, then I'll end up saying more than we need to at this point. So this is what I'm going to say. The integrand right here is what? 1, right?
Yeah.
But imagine that there's a quantity that you define by multiplying area by something. Oh, yeah, wait, mass isn't half bad. Guys, what if the mass density wasn't in terms of mass per unit length, but mass per unit area, right? Then, everyone, actually, help me pass this around. This will be fun. You all get, back a unit area. This is your personal DA. Yeah, I know I don't have enough. But come to office hours and I'll get you more. Okay, so, yeah, maybe divvy it up for the mean thing. Here's 2, I think you guys can split across here. Yeah, so I got a 3D printer and all the printing is flat sheets. Somehow I think I'm doing it wrong.
And we have
Alright, here's a DA.
together we make DA. Urethra.
Is he pre-med?
Wait.
Alright.
Alright.
Yeah, I'll get more.
Why did you draw that? That was.
Alright, I know, so who has too many unit areas per unit length actually? And we'll share. Oh yeah, wait, can you pass one back to Sibling? She's the one in the back. Okay. Also, remember this? You remember that? Here's a bunch of little DAs. Okay. Mass of a region, of an area region, right? You have the density, mass per unit area. What do you need to multiply that by? A little piece of area, right? So if you're trying to find mass, what do you put inside of the integrand? Mass is equal to the integral, it's a double integral, right? Over the region of integration, so dA, right, which is dy dx, dx dy, what do you put in here? What do you have to multiply each little piece of area with to get its mass? You have to multiply by its density. Yeah, density as a function of x and y. Now you're in 2 variable length. Right. Very cool. So that's why it helps, back to your question, Diego, to not always just go back to the single variable calc way that it boils down to, because sometimes you'll put other stuff in here. And yes, you could do, I guess, that density times f of b minus f of a.
But then it's kind of like the same thing, you evaluate that.
Yeah, yeah. However, once we go to triple integration, you'll lose that flexibility, so it's kind of a, you might as well get on board with it for practice. All right, so I want to go back to this, and now I want to do the same area that we're trying to find, but I want to do it with the other order of integration. Go back over here. I'm going to do my best attempt at redrawing the region. See how well that's going. I'm already cheating. Okay. All right, so we have here FB x and here x, and we have our bounds from C to D, and we're trying to find the area of this region. And now I want to express that not as integrating from dy dx, but integrating, what's our integrand if we're trying to find an area? 1 dx dy. Okay, the rule again is to start from your inner variable, which is x, right? When we were starting from y, we drew arrows in the y direction until we met our region and exited it. Now we're entering through x. So what direction do our arrows go?
From C to D.
From C to D, so we're starting, but so yes, and start from before there, and go. Okay, where do we enter our region? Well, we're entering it here on this line, right?
FG of C minus F.
Hang tight, hang tight, hang tight. You'll understand why in a moment. We're entering our region at this line, right? What is this line? What variable are we defining stuff in terms of? No.
Oh,
What's our inner variable of integration? So I need to know at x equals what do we enter our region?
so C has to equal,
X equals c.
oh. the
Right?
next one has
Do
to-
you agree that no matter where we're entering our region, we're always entering at x equals c? This is our region, right?
But now it's,
But remember, c, that's a constant. That's our x where the x variable where our slice begins. So the lower bound on x is c. But I think I know what you're getting at, Noah. Let's keep going. Where does x go to? We enter our region at x equals c.
but we don't hit D at every single point.
Exactly. Okay. So I know we're on the same page. We don't hit t at every single point, and I don't find my chalk every single moment. How far could the white chalk have gone? Oh, it's hiding. All right. We always enter at x equals c, but maybe sometimes we exit at x equals d. But is that the case for every part of our region? No. So we need to be more robust. Okay. Let's try. So for some values of x, I enter at c, and where do I exit? At this line. So let me now, instead of writing it in terms of x, do you trust that that I can write this as x is fa inverse of y, and x equals fb inverse of y? What order of integration do you prefer, by the way? Yeah, and Bond, do you have
Where'd you get the inverse from?
so basically that just means this function was originally y as a function of x, right?
Yeah.
So what if I want to solve x as a function of y? If I do the inverse of the function, right? If you don't like this, good. What does that tell you about order of integration? Do it the right way. And the right way might be different for different problems. But what's a way you can scope it out is to start by drawing the lines. If you find that this integral is going to be a pain in the butt to solve, you might be onto something. Change the order of integration, and you see that when you go in the y direction, you always come in at this line, and you always exit at this curve, no matter where you are. That's a lot nicer than this, but indulge me, because we've got to drive the point home that you make good choices about order of integration. So we enter at x equals c, and for part of the region, we're exiting where? Yeah, we're exiting at the inverse of a. In fact, for all of this part, right up until this point, for this part of the region, that's what we're doing. So I'm going to call this area A1. And annoyingly enough, what does that mean about our total area? You don't get all of it from just doing one double integral. What are you going to need? Yeah, probably two pieces. Okay, so for the first double integral, right, for A1, let's do our bounds. It goes from C to, what did we say? From here to, what's this function called? F inverse.
FA inverse of 1.
Yeah, okay. And now that we've done that, congratulations, our bounds in y are what? Our bounds in y get to be constant, because we've already handled the dependency. So it's whatever this value is to whatever this value is. Let's call them, I don't know what to call them A and B. Let's call them,
C and F of,
well, because they're lines, right? They're number. These is lines, this is beans. So let's just call it, I don't know, V and W. So going from V to W on Y. We'll follow so far? You see what I'm doing here? Yeah?
I didn't understand the part about lines coming in. How does that represent, like, finding areas?
Yeah. Oh, well, but these are not areas in 3D, are they?
No,
Oh, 2D, oh, I heard 3D. Oh, yeah. So it's always length times width, right?
What is
Area is length times width,
yes.
generally, right? So first I'm going to find out what my width is. So my width is whatever my function is at this point minus what it is at this point. right? That's my width, that line,
Yeah.
and then I multiply that by the height, right? Okay, well this width, or this length, what have you, is not always defined in the same way. For part of this region, it is this value of x minus this value of x, right? Where this one comes from that function and this one is a constant. But that's not the case everywhere inside my big region. Because once I get up here, where does my width start? It starts here, right? And then where does it end? It ends here.
And where's the height?
The height ends up being then this.
Right.
But the thing in double integration is the inner variable is the only one that you need to worry about as coming as dependent on the two variables. Well, so yeah, the inner bound is the one that's a function of the outer variable, right? Because y is a function of x, or x is a function of y. These are curves. These are not just rectangles where each of the bounds is a constant.
So how does that relate to double integration?
Oh yeah. Well, we're figuring out the bounds on one of the variables of the rectangle, and then the bounds on the other bounds of the rectangle, and it's double integration, so it's the product of those two things, length times width. Of the office hours, it'll be fun. All right, more questions? Yeah, like not a bad question, and there will be time for this. Some of it's just in the end.
Is this only because our shape works well? What if it's a little different?
You think the shape works well for integrating x and then what?
No, I mean, like, let's see, I'm drawing, I'm not getting the same result, and it's just slightly different.
It's slightly different? I mean, oh, because maybe you drew it better than I did.
No.
No? All right. Do you have a similar situation?
Yeah, like shape. Is it the section where it's like CMD, another section where it's like.
Yeah.
Oh, like this little piece?
Yeah, there's a piece of.
Oh yeah. So I ignored this for simplicity, but it is a thing too. Yeah. So there's actually three pieces. Damn it, yeah, you found me. So this is A2. But do you see that the only way to solve this is to go piecewise? So this is another wedge. Let's do this wedge as well. This A3. Dx dy. Where do we enter x to get into this slice? Over here. What function are we entering at? We're entering at this curve. What's this curve? FB inverse of y. And where are we exiting it? At least that's nice. What's x here? D. Okay. And what are our bounds on y? It's whatever this is and whatever this is. Let's call them P and Q. And then that gives us A3. And then we would do the same thing for the A2 part. But more than this specific shape matters, what is this here to illustrate to you? The order in which we do our integration has a direct impact on your need for Tylenol in this world. This is a big headache. This is awful. So make good choices. Make a good choice. One integral, and it adds up. Okay, questions? All right, so order of integration matters. So we have about 10 minutes left. During that time, I would like to do a problem, because we got whiteboards and we haven't been using them, but we're very good at using them. So we are going to do the following. And this rag is better than the eraser. Pretty good. Okay. Okay.
Oh, and the faces, they're becoming a thing.
Point him at the camera so this goes.
Oh, okay. Now there's Luna and the dad Roblox and that. Whoa.
Right. So example one. Okay. And examples problems are going to be in the morning. Sure. Okay, you guys. So find the area of the region between the line y equals 4 and the curve y equals x squared from x equals -1 to x equals 2 using both orders of integration. Okay. The very first step, step 0, not a measure of importance, but of how primordial it is please, 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 for partial credit for your own understanding, draw the region. You're not going to be able to make sense of it if you can't go back to an image. Even if it is floating in your head, it's otherwise complicated. That's why journaling tends to help. All right. So what I mean when I say both orders of integration, dy dx and dx dy. Do both of them, yeah. So please work on this with each other. There should be a lot of talking over here. Help each other out. Pyramid scheme is good stuff. And we will talk about it as a class in a couple of minutes. It's not what we do.
I usually.
Hey, Bob. Oh, yeah.
Oh, where? Never fear, marker is here.
It has ears. Oh, it's Avatar. I thought you were like Stitch. In 4 minutes, we'll get together. We'll do it together on the board. Pyramid scheme, guys. Talk to each other. It'll be fun.
Wait. Were you like the rules and like crazy wildfires always came to what the
Maybe. I've been out.
No, it was like during the school year.
Probably, yeah. I feel like it just isn't.
I don't know if this is the inspiration you need right now, but grade cutoffs are different from what your numerical numbers on the exam are. So again, like
No, I had it a lot back home.
90 is not going to be the cutoff for any of this class. That was so long before you took this.
Oh god.
I cannot disclose them, but they will be fair. They will be fair.
It was like that for only like a day.
Do you mind creating?
No, you're good, okay.
Just like to make sure.
Oh, really?
Yeah.
Anyway.
Yes, and wait till there's but if I don't go to what you want me to, then
On the outside, I'm going
oh no, do all this stuff. Yeah.
Wait, what do you do? What
If you go over that one row where you can like flip the patterns and it moves.
Yeah, it's like
Not flip the patterns, but like switch the. Oh yeah.
Alright, like we integrate this innermost components. Is something like importantly, we can swap them as long as we
Yeah. I think I might actually do a double in 12 hours.
What are we doing?
I think it's like do better. It's like just the better 112. 112 is kind of a weapon. It's like
I sometimes wish that I locked in more. It's actually I agree. I just like. I feel like getting to this stage, I feel like I more appreciate what it means to spend 4 years. And that like makes me wish I'd taken that up. Like, not that I want.
I think it's so subjective, but I'm fine. I don't think I projected it.
You know, I did do a little dilly-dally.
it's just super bad.
I see ball. I see ball.
But like
From 4 to 0.
I don't think people should double
Zero to
just
four.
say like I can't even say that. I don't know. Honestly, this is like not that bad of a double major.
Yeah. And like, are you doing anything?
No, it'd be a fly.
Oh, that's what I was
AP in general is.
This is right.
I will say, like, let's say it's not like general.
No, I
it's
just
just now I have double
I'm very interested.
Check it out.
That's like in life. I remember I was trying to do the data science
That's not right.
like if and like I might if I do it, I might just switch to 12. I also could just easily do the semester.
All right, guys, we're gonna work on this
I'm
together.
probably gonna do.
So, step zero is very important. What are we gonna do? We're gonna sketch the region. Let's do that. All right, step zero. Okay, so what's the region look like? What's the region of integration? What are our curves?
From the parabola to y equals 4.
From the parabola. I like that. So what parabola? This one?
I mean, that's all right.
That's all right. Yeah, it's a bit chunky. Yeah, I think to make it so wide. All right. And then from what to what? -1 to what? To 2. So okay. And then what are our bounds on y? 0 to 4. So we're going to go up here to 4. So our area that we're trying to find is this region, shaded in 2. We have plenty of chalk. It'll be okay. So this is our region of integration A.
Wait, I feel like you cut out some of the parabola though.
Oh, yeah, you're right. Shh, what am I doing? So what we're really integrating over is until 2. 2 is, I'm going to call here, yeah? Okay, so it might be helpful at this point to, what was that?
Oh,
Yeah?
yeah, we can label points in the perspective.
Yeah, let's say what's the points. Okay, so what is this point? -1, 1. What is, do we have this point? -1 and, wait, no, is that right? Oh yeah, -1, 4, yeah. Okay, this point? 2, 2. Sorry, 2, 4, what am I doing? Okay, and this is the origin, cool. All right. Which order do we pick at the Masochistic Institute of Technology? The easy one or the hard one? Easy one? Okay, let's do the easy one first. Okay, so what is the easy order? What's your intuition and why? Someone, hi Sibling. What's the easy order of double integration? What's for this particular problem? How do you want to start?
The dy dx?
I think dy dx is solid, yeah. We're going to go in the y direction first and y sibling. When we go up in the y direction, where do we always enter our region?
The x squared?
At that curve, yeah. So we're always entering at y equals x squared. And where are we always exiting, no matter where I am here? At 4. Okay. Now that we've taken care of the dependency between the inner and outer variables, our bounds in x, our bounds in our outer variable are?
What?
Our bounds in our x now, our bounds in our outer variable are?
-1 and 2.
-1 to 2. Very cool. Okay. Ooh, something tasty is on its way. But to earn it, we must do it in the other order of integration. Because dessert is always last. All right. All right, you guys. dx, dy. What do we do? So who's gonna tell us about that? No.
So we see that there's a horizontal line of
Yeah.
x of y is equal to.
Of y is equal to?
No, x is equal to -1.
X is equal to -1. Beautiful. So x is equal to so that's our inner bound of integration for part of this at least. And where do we exit?
Until square root of y.
Yeah.
For some part.
X is equal to. Do people see why x is equal to the square root of y here?
Yeah.
How do we get this?
Because x squared equals y.
Yeah, because this y is x squared.
And it's positive.
So x is equal to positive square root of y on this side. Okay, so square root of y. Okay. What are the bounds on y? Is this the case for every part in our region? Are we always entering here and exiting at that curve? No. Where does that change? At the bottom, right? So for this whole area, this piece over here, we're going to call this A1. We always enter at x is -1, and we always exit at square root of y. So what are our bounds on x for that region? Where does that start to happen? Where does that end? At -1 to what? From -1, from x, from y is equal to, oh, sorry.
Y is equal to 1.
Oh, yeah, what the heck am I doing? Sorry. Bounds on y. Y is equal to 1 to what? To 4. Right? That's describing this height, and then we have our function here. Okay, but we're missing a piece. What's the second piece? The bottom. Okay. Dx, dy. In the bottom, what are bounds in x? Where are we entering our region? Aha. Well, x is equal to negative square root of y.
It's a positive.
2, you've got it. Positive square root of y. Right, so this whole thing is area 2. To positive square root of y. And what are our bounds in y? We just enter at 0 and we exit at? Okay. This one on the top gives you, did anyone actually compute it? I think I made it a pretty number. 9, it is 9. All right, what is the sum of these integrals? Yeah, well, what should it be? It's the area, it's area of the same region. It's 9. This is a much more complicated way of writing the number 9. You can use it to impress your high school friends. Okay, because we know that the area is A1 plus A2, right? We broke the whole area into chunks over which we have easy bounds or easier bounds, and we add those up together. Okay, questions? People are good? People have questions? Did this help with the order as well? Okay, so let's chat after. Okay, Evan, it's made you all cookies because you all kicked butt and you're done with the tests.
Awesome sauce.
Go ahead. What's the SOP? Just come up and grab them?
Yeah, just grab them.
So guys, or let's turn at the front so that way that I can collect your whiteboards too. Let's do that.
Oh, sure.
That's a lot of cookies.
Wow! Oh my God! You have something. All right, cookies at the front. These are based on whiteboards. Back here at the front. Thank you. Oh, you can keep your GA. I have 20,000.
Oh my God.
Yeah, exactly.
Okay, let's do it.
Whiteboards over here.
It's okay. I am proud of you.
Plus 4. Minus
So something's up.
some fraction. That should give me, it won't give me
I know. Thank you, Evan. So y has the 4. So 4 cubed is 4 cubed, 64. Square root of 4 is 8. 8 times 2 is 16. 16 over 3. Plus,
Let's work on the plus side.
that should be a 3.
That's pretty good.
Correct? Because it's 4 minus 1.
Oh, no, I did, why?
Plus y, yeah. So plus 4 minus 1 way. Yeah, the ginger color.
I have actually a question.
I feel like this is.
It's an algebra thing, but it should make.
Yeah, I mean, I'm curious if you do it this way, if you get, oh, because this is the crazy one. Did you get 9 by doing the yellow?
Yeah, sure. Maybe, did we get 9?
Check it, you can
You
figure
got,
it
you
out.
got a refraction, right? You got 27 over 3.
That's 9.
Oh! Wait, that's not.
All of you on the exams were doing this, I love this. And that's okay, it happens. It's, you were doing, oh, the coefficient is 3 over square root of 3. What does that equal to?
Wait, no, but 23 over 3.
You all got points for doing it this way. I just thought that was pretty cool. That like, so like, I don't encourage you to rationalize all the denominators, but one of these you can do. Oh yeah. 3 divided by square root of 3.
Really?
See, that's good. Square root of 3.
I'm 19. I'm
Plus,
But like, I don't know. It's just one. It's the only
Why
time
is
I've
there
ever
lecture
rationalized
and
fractions.
lab?
I have this.
Why
Numbers
is,
in
I want
general,
to take into this.
A over root
You
A.
should
In fact, oh, I wanted to do it general way. A to the n over n
Beats
root
this
of
one.
A.
Just
Did I-
multiply this way, because,
I think I
Is
see
this
that.
the case? A to the n times A? Yeah, that makes sense. A to the n times A to 1 over n.
yeah, okay.
Wait, no, by that measure, it's just square root, right?
Over here.
Because you said I.
Okay, it was right. Okay,
Yeah, I've
actually, my
actually
algebra was wrong.
talked
Okay, the algebra was wrong, alright. Yeah, that is, but now I think I got it wrong.
No, it's mine. My other A2 was wrong.
What's your score?
But my A1 was right.
I told them what
Finding
is a better
maximum.
class I would take, but.
Wait, are you gonna work on this piece set tonight? Nope. Okay. Oh, okay.
Maybe.
If you do, can you please work on it together? Can you please?
Christian, I have the question.
Okay, I want to make sure I have it.
Okay.
I'm second.
Yeah.
Okay,
You're good, I
who's here with questions? And did I send a question? Say
I
it.
just have a question about what he's on the east side.
Oh, yeah, excellent.
Actually,
Sorry,
No, no, it's okay. So number 1 is double integration. You can definitely start to do that. Number 6, I think also.
I
So
know
5
that.
a.m. email.
What everyone is telling me is that I know that you blended in the eigenvector, but I wanted to know why that works for any delta.
I
There's
guess
gonna be some that if you explore the eigenvector path, you know that.
yeah, if I have my answers, we're about 4 minutes.
Number 1 is.
Then like,
And
if you would
therefore,
agree with
the
how
eigenvector
versus.
Yeah, polar coordinates
not.
will make it easier. That's okay.
Oh, especially if you like, and you know all other vectors will follow the same.
But I don't want to lose points on not getting it.
When we did what?
Because like you
Or when I
did.
did point one.
Oh yeah, if you did polar, then this might be
And
easier.
I'll try and do that.
But we'll talk about it
because I
more
feel like-
on Friday.
And then we'll show me exactly what I got right, but it was.
I got number 1.
That becomes.
You can do number 3, because that's based off the last one.
Oh
Oh,
yeah.
yeah.
You can do number 4.
I can just show it. It's,
You did this. Yeah.
I think I
I
have
feel
it.
it's
You can do
easier
number
for
5.
explaining.
5 is long, but you can do it.
It's on the last piece.
And then
Oh.
Either
I feel like you can do number 1, number 3, number
I need
4, number 5. 1, 3, 4, 5. I'm off the start to defend that out.
And then
6 is
doing
the
that
polar, it's not too bad.
when
The polar number 6 is actually much
for
easier.
it to be positive.
Yeah.
Like this has to be greater than 0 to be positive, and this has to be less than 0.
Sure. Okay, so we have you,
But I
and
wanted to
then we
know
have
why you
David.
said
Okay,
that.
let's check.
I know it's on the right graph, but how exactly do you know that it's
Yes, oh, I realized I never actually did an example of actually expanding. So let's do this guy
about
by
this
expanding,
path
yeah.
being one of the
So the
paths.
first thing we can do is,
Right.
we'll have to do this next time, that's really important.
You know that.
I always do,
Once
because
it's
the triple integration is
that's always open down.
is I write inner,
approximation. So if you explore the eigenvector.
and I say inner is equal to, and I just do this part.
And this does not.
Which is why you can just say,
Yeah.
I think that the determinant of the
2 or
hash.
4, yeah.
I said it more quickly.
So if it's greater than 0, then it's positive definite.
Then I do outer, which I know is integral from -1 to 2 of inner. Yeah.
Because the determinant is the product.
That's -1 to 2 of 4
So then it's
squared. But I think you understand
I know
this
it's
one.
true.
Because I know there's this other caveat where it's like, what they
Well,
taught
it's-
me is that you have to look at both of these.
So integrate this, right?
So
What's 4
then
minus
you
x?
just
What's
add
equal
it
to
up.
4, right? Is 4x minus 1/3 x cubed.
Oh, yeah.
Two, so
Oh,
on.
yeah, and
And
it can't be negative.
One thing that I will
So
often
one
do,
of
especially when
these
we get to whole to triple,
Yeah,
and is I'll be explicit about what variables we're talking about. Because when you do 3 variables, it will become a mess to figure out what
And
you're
then if
talking
it's
about.
0,
So this, it becomes.
you have to look at it again.
That's the good, it's like an integral
If it's
inside of the
negative,
other.
it just opens down. get a 0
That is true,
but I don't know what they were wanting.
Yeah.
We're looking
Like
at
the-
0. Oh, wait,
it's
what's
not
that?
even-
Oh, parts A.
Oh, right.
Once you integrate.
So is it that
more
if it's minus this
complex, it's helpful to
But that was
if it's negative
like
because
density, like anything with
this,
integrand
then
is one.
Some of these are symmetrical. And then if it's negative because of
Yeah,
this,
then
then
you-
it opens down.
Because of that.
Plus, I think the real thing I have to say for this is, really want one.
Yeah, like they wanted,
Makes money, but we
but
don't
the point
show
of
it.
that was to try to
Like,
get.
when we do this method of iterated integrals will make
I get that.
triple integration make a lot more sense.
Because I
than
assume that
thinking
was
about it, like single variable calculation, you could maybe survive with it for double. Once it gets triple, it's gonna be a real stretch to make it coordinate.
Okay.
Oh, yeah, so this is like,
I just
I'm
think
like,
like-
if I'm like, hi.
No,
In theory, you could do
And
this.
think about it, in single variable calc, we did find volumes at some point, right? But think about all the mangled crazy stuff you have to do to integrand to get a volume. You have the shell and the washer and the toaster and this is the whole thing. No stuff, there wasn't a toaster.
So how do you
But
So
like,
this is why I was.
yeah, this washer.
This is bigger than
Because I remember now that you bring it up,
I didn't know.
In class,
This is
that
negative
was-
shell, this.
No, I said like.
But think about how much like you had to, how much overhead there was in setting up the integral, because you had to think about the revolutions and all
I
that.
think like potentially.
Maybe a point, a whole point in this.
No, I was gonna say.
Is this a tactical AirPod costume?
It is.
Oh my god.
You see how tactical, yeah, that was my grenade.
Same thing, so if you got it for one.
You got 3 E, you get 3 E, right? Okay, and then.
Oh, yes.
You remember the.
Now, for the, if it's negative.
Yo te veo.
Because I got.
Porque no te están, yo lo veo. The one that everybody struggled with, it, I wanted it to be like a trick question, or like wanted it to be one of those where you're like, ah, Christian, you're
So
reading
that-
so much work. Is the quadratic function.
This is greater than 0.
Oh,
Because the function
this is
itself, I remember if you were the one who wanted that right.
That means-
But f was already quadratic, f was as
So
far
then
as
they're
you
both
read
negative.
It was x squared
Oh,
plus
they're,
y squared.
It's
When
not.
this is negative.
now I see
X squared
what,
plus
like,
2xy.
The term
No,
is
it was
positive.
3x squared plus y squared plus z squared. That's
And then
quadratic.
If you only have your always like, I can get
Makes
this.
sense.
Okay.
You
Yeah,
get.
I
If people did hashes and notes, I gave them all but 1 point
I do think that.
because like they get it.
Okay,
Because
that's
if you have the time, you'd end up on, ooh,
Thank you.
it's
Getting it. Well, we're asking.
it's yeah, no one did it that way.
I feel like too, especially the one with
Solved it out,
the,
landed on it.
the problem making with.
People who landed on it being,
Like, I feel like I was
the ones who
money
didn't
when
bother
I
to
wrote
hash.
it down, it definitely was.
Yeah, like, I think the thing
15.
you were writing out was correct.
So the mean was a 7,
I-
and
and also
the
just
was a
wasn't
15, that's
all
why
of
I
it. Like, I feel like-
score within 1
Like, if I
centimeter.
can told, like, okay, we're just.
That's what I'm saying,
You're saying it, but
55.
just say all of it, maybe.
Yeah.
Or like,
Because that's at 55, I do want to hear.
see, I know that's something to do with physics as well.
Wait, no, what'd you score if you don't?
75.5.
So, and you
You
too.
you could.
You're all within the
Drama
70.
queen.
Yeah.
As a fellow drama queen, I have decided.
Can you justify that? Because I use, you know the notation I showed you with Feynman?
Yes, I
I
use
use
that.
that.
What do you use it?
I lost 7 points.
We read it.
Oh, we talked about it.
Like, as in.
Oh, you did?
I think drama queen about it. I had my.
Thank you, Kate.
Don't lose it again.
Oh.
No, I won't. He's please. I thought he was grading it. That was just for him, you know. I didn't.
Oh, no, but even I told you, Beyonce, to take it easy on some of the notation. Pero,
You know, it's gonna catch on. It's like
It's not, no, it's.
What is the meme from Mean Girls?
Oh, just even go here.
No, the other one, Beyonce. Fetch, oh yeah.
That's just not
Never gonna happen,
Ah.
that
Well, no, like, and like, don't get me wrong, David, like, I'm mostly trolling you. And, like, it's cool.
it's
What are you gonna do in relativity when it's out
The
there?
thing is, if I'm rushing, it's gonna take me a while to write and erase all this. This is like
Yeah, no,
That-
I'm gonna try.
every time in my calc, my teacher hated me.
Then don't rush.
Yo, so then don't write a test.
Yeah,
that
don't
makes
write a
me
long
rush.
test. That was, yeah, that is a valid diss.
Anyway,
So I was like, oh, is it gonna be too easy or too hard? I'm all ended right
let
on
me take a
time.
photo of this and then I'll
Thank
talk
you
to
so much
you.
for
What is this?
the
Yes.
Wait, are you using like the single letter Feynman things?
Yes, bro, I fucking
Have you read,
Me and Feynman are one of the same
Surely you must be joking.
I don't know about that.
I wanna read that book, it's got some crazy quotes.
Yeah, we read it in freshman advising seminar, and it was such a good use of time. record. You guys can go. Hi, Sadie. Office hours today 4 to 6. If you guys want to come to us.
Sadly.
You
have vegetarian?
Oh, we have vegetarian.
Yeah.
I feel like I was missing a point on the I feel like I was asking a
Sure.
I was under. I feel like I make the case that I was probably under.
Remind me about the question. I don't remember which one is that.
You had 3 matrices. A and C were symmetrical. B was not.
Aha, okay.
And so I drew out each matrix and saw that the lambda was the scale between input and output. Because
Yeah.
we kept saying that in class.
Well, yeah, that's the definition of an eigenvalue.
Yeah, and then with 3E, it's like make a more formal definition about symmetric matrices.
Yes.
See, I didn't realize we were talking about E about symmetric matrices because I thought we were talking about in general, make the conjecture yourself.
Oh, how did I phrase the question? Did I say between A and C? Or
A through C.
Oh, yeah. Oh, I see what you mean. Ah, okay. I guess I should have said A. I'm going to write it down for next year. A and C, like about A and C versus matrices. Matrices like A and C versus matrices like B.
But I feel like at the end, by the point of 3E, I was able to like, what's it called? Make the point, like get to the same conclusion that the symmetric matrices had perpendicular eigenvectors. And I made my point with my lambda case, my eigenvalue case. So because of that, could I get these points back?
Honestly, why not? Did you sharpen that?
Yes, but he said to go to you guys because I need to defend my point. It's a little.
No. Like I agree. I was just saying like I didn't want to like go over.
No, and I appreciate that. In general, I trust you guys. Like, if you have that, but that's a conversation we didn't have. So that's cool.
Submit the request then.
Yeah, submit the request.
So should I do for 3D and 3E? Because I feel 3D is still kind of wrong.
I feel like just for 3D, like I agree that you kind of.
Like I definitely missed the point for
Like
3D.
I think there was reasonable credit taken off for.
Yeah, because I said the equal and opposite eigenvalues or eigenvectors make it perpendicular, like the scale.
Yeah.
But not important. I'll get that there.
Who made the cookies though?
Evan,
Evan made it. They make very nice cookies, and I don't know what you make them out of, Evan.
should I make this? Can I make this right now? Or can I don't really know how to do that.
Oh, you like
It's
ginger?
very compulsive.
They're a pumpkin.
The
they're so
pumpkin?
good.
Oh.
How do you? Oh, request regrade.
Very good.
Read. Should I just write request?
Wow, they're big.
Oh, do you know how to submit a review?
I did. I wrote request on my request. If that counts.
You know the Chips Ahoy chewy cookies, the chewy ones?
Mm-hmm.
Oh,
This
that's
is
what we
like the real deal version of it.
No, it's like, you know how normally you put in like a teaspoon of like baking powder or whatever? Turns out if you add 12, then you actually get a different consistency in your baking.
Really?
Who would have thought?
Aló. Hola Alicia, ¿estás por allá? Yo estoy a 2 minutos, estoy caminando para allá ahora.
Request.
Let me-
Okay, 1 minute. It's Spanish time. I need to run.
Yeah.
Sorry Andrés, que me tengo que ir deprisa, pero se lo voy a tener pregunta.
Yeah, well, I still don't understand how you get your multivariable equation.
Or,
With the, did you talk about the double integration
Yeah,
stuff?
bounds. I don't understand how you get bounds.
So everything else is happening.
You're something.
and then,
Well, I don't know if I'll be able to today because I have a Russian COU, I think.
Oh, what about tomorrow?
Tomorrow?
Or, mándame un email. Yo quiero responder tu pregunta, solo que tengo que ir cogiendo ahora.
Sí.
Pero tú me lo mandas y hablamos.
Okay.
Porque hay muchas maneras de explicarlo y posiblemente hablando tú y yo descubrimos una manera mejor. So, estoy totalmente abierto a eso.
Yo también, pues.
Es verdad, él no es gringo.
No es gringo.
No, he's not a gringo.
Yo soy niño mexicano también.
Wait, Andres, are you Mexican? I thought you were Colombian.
I'm Mexican.
Well, I'm Colombian.
There's a couple Mexicans that I thought were Colombian. I don't remember.
No, Alejandro's.
Alejandro's from Colombia, yeah.
Alejandro's good?
Yeah.
Mm-hmm. I don't know if she has the Paisa accent, one of the various Colombian accents.
Are we?
I mean, Colombians are super pretty similar anyway, so like.
Do you think the Colombians would agree?
You like your side. Are we gonna go to lunch?
But like, it's not different though, it's pretty similar, like, pretty alike. It's like Canada and the United States.
You feel that way? I feel that maybe like more like Colombia and Venezuela have more of that stuff in common. They're right next to each other. They have a little, like, even their accents sound similar. Pero no sé, ustedes chingones tienen su propio sistema. Yo estuve en Chihuahua, and that was very cool. I had some good cheese. I went to to like a restaurant or like a bar, I don't know, and I ordered a beer. Te dan las bodegas esas grandísimas de cerveza. I thought it was gonna be like an American beer. No, they're huge. Like, what's it? Maybe. What's the word you guys have for like the one that's like a big, it's like a 1 liter?
Big ass beer,
Yeah.
that's like a Wama. That's
Ah,
like a
1
liter of beer, like.
Yeah, it was a liter, yeah, it was a proper liter. Like, I'm thinking it'll be like in the US, you order Miller Lite or some other sleazy beer. Like, what do I order when I order beer? I rarely order beer, but I want. And then I kept given this, and I ordered 2. Because I thought, oh, 2 beers. Oh my God.
You get 2 liters of beer.
Yeah, that was some night.
Oh, people just chug those in this. Yo, no,
They do.
beep beep, you got.
Whoa, what? Beep beep?
You got.
Okay.
All right, you guys.
Have a good day.
Well, see you. Take care.
Bye.
Oh, I forgot to.
Now it's time for the next round.